Let's talk about table partitioning. We have dealt with this card sales data in our demo. The size was pretty less. Let's say we have car sales data for a particular country or for big countries like India, US, and you want to find out the car sales for a particular year for that entire country. Obviously, the data set would be much larger in multi terabytes in size. Let's say you have written an HQL statement wherein you want to find out all the cars that were sold in the year 2022 in the country India. And let's say the car sales data set is 10 terabytes in size. So what Hive will do is it will create TAs or map reduce tasks which will scan this entire 10 terabyte data set and get you the result that you want, the number of cars sold in the year 2022 in the country India. So you can imagine how long it will take, and you can imagine how much data it has to scan. Because this dataset contains data for multiple years, let's say for the last 10-15 years, the MapReduce task or the TAs DAC would have to scan last 10 to 15 years of data to find out only cars sold in the year 2022. So how can you solve this? How can you optimize the performance of this query so that it takes lesser time? So that's where partitioning comes into picture. What if you partition the sales data by the year? So the data would be partitioned by each year. So for the, let's say for the last 15 years, you have 15 terabytes of data. And if you create 15 partitions, each partition would have only 1 terabyte of data. Now, if you run the same query again, it will go and look in the partition 2022, but now it will not scan the entire 15 terabyte. It will scan only 1 terabyte because a single partition contains lesser data than the entire data set. That is the whole and sole purpose of partitioning. So you break down a large data set into smaller pieces based on a certain column. In this case, let's say the column is model year, and this column is called partition column or partitioning column. So the car sales data would be partitioned into multiple small data sets, and each data set would contain records for a particular model year. For example, this particular data set would contain cars sold or cars for the model year 2021. This will be for the model year 2022, 2023, 2024. So these are smaller data sets. This is the entire data set. Maybe if you consider the size of each partition is 2 terabyte, then car sales data by itself is 8 terabyte. But individual partitions are smaller, maybe 2 terabyte in size. You can partition this further, let's say based on color, or you can have multiple partition columns also. So in this case, what will happen is that this data set and this particular data set would be partitioned further in colors. So in this case, let's color red, color blue, and similarly the other partitions would also be partitioned into smaller partitions, and each of these partitions would have their own data. Now let's say for simplicity's sake, this 2 terabyte data size has been divided into 1 terabyte and 1 terabyte. Now each of these file is 1 terabyte in size. Now let's say if I query give me the car with model year 2021 and color red. So what Hive will do, it will go ahead and create a task which will go to this partition which is model year 2021, and then to this partition which is color red, and then only scan this particular data set which is only 1 terabyte in size. So if you do not have this partition and you run the same query on this large data set, the entire data has to be scanned. So this is what partitioning is. Partitioning is very common in RDBMS world, like relational database technologies like PostgreSQL, MySQL, Oracle, DB2, etc. As Hive also tries to behave like a relational database, that's why it implemented or introduced the partitioning concept. As Hive has 3 table types: managed table, external tables, and temporary tables. We'll talk about partitioning in managed tables and external tables. So you store different data based on columns in different locations. That's what partitioning is. and separate data directory is created for each distinct value combination in the partition columns. So you can have model year as the partition key, you can have model year plus color as the partition key. So if you go back to this particular diagram, as you can see, we have two partition columns, model year and color. So this combination of model year and color would render only one dataset, which is much smaller than the entire dataset size. So model year 2021 and colored blue would give you one more smaller dataset. Model year 2022 color yellow would boil down to again a smaller dataset. So that's how you can have separate data directory for each distinct combination in the partition columns. As I have already told you that queries become much faster by partition pruning. Partition pruning is nothing but discarding the partitions where the values are not there. So if I go and check for model year 2021, the partitions with model year 22, 23, 24, etc. and obviously the other partitions will not be queried or scanned. There is one condition though. The where clause in the SQL statement should contain the partition column, which is called partition filters. So if you do not mention the partition column, Hive will go ahead and scan the entire dataset, or it will go ahead and scan all the partitions because it does not know which partition to look into, because you have not mentioned the partition column in the where clause. If you mention the partition column in the where clause with a corresponding value, it knows that okay, if my model year is 2022, I'll have to go and take a look at the partition with model year 2022 and then go to the dataset. So if you have multiple partition columns like model year and color, you'll have to mention model year and color both in the where condition. So it will go ahead and narrow down its search to only that directory which has model year 2022 and let's say color blue. This is how you create a partition table. You have already seen the create table statement and you mentioned this additional partition by clause. You have to additionally mention the column name and the data type. The reason you mention the column name and data type because these columns are not mentioned in the create table statement. So let's say you are using model year as the partition key, then you should not mention model year in the create table statement. And if you have to add partitions, you can use this alter table command to add partition followed by the partition column and its corresponding value. You can use show partitions table name to see all the partitions for a particular table. If you use describe extended, it will also show you the partitions. There is one configuration parameter Hive MapReduce mode strict and non-strict. So what it does, if you mention Hive MapReduce mode as strict, then if you run a query on a partitioned table without having the partition key in the where clause, the query will give you error. If you mention Hive MapReduce mode to non-strict, you can run a query on a partition table without the partition column being in where clause. What about external tables? It is more or less similar. You create external table partition by the definition is exactly the same. One thing is that you do not need to mention the location clause while defining the table. So you'll just create the table and mention partition by column name followed by the data type. You'll have to use alter table statement to add each partition separately. So value of each partition key must be specified, meaning let's say this is the alter table statement. You mention alter table add partition and then you have to mention the partition column and its value, and then you have to add the location. If you have multiple partitioning columns, obviously you have to mention multiple partitioning columns as well. We'll see all these in our demo as well. Now there are two types of table partitioning. One is static partition and the other one is dynamic partition. So what is static partitioning? Static partitioning is nothing but manual partitioning. So you create a table, let's say you mention partition by model year and the data type integer. You have to load the data files individually for each partition, meaning that if you have noticed our car sales data file, it has records of multiple vehicles with model year with different model years. But if you create a static partition table, you'll have to separate those files, meaning that you cannot have a file with model year comprising of different values and load that file to a partition table. You cannot do that. You have to separate out those records with similar modular and have to use those files to add the partitions individually. Something like this: load data file into table followed by the partition clause and the value of the partition. So this file, the file that you are loading, should only have value with model year 2023. Obviously you can have model year with a different value here, but it'll give you data inconsistencies. So make sure that you use load records with model year value 2023. Similar is the case here also. You have to load the data into this particular table and the partition will be model year 2022, and the file that you are using to load the partition should have records of cars with model year 2022 only. So that's why correct data has to be loaded in correct partition. File should contain data corresponding to that partition. So if your file contains data that does not belong to that partition, you can load that. Hive will not raise any complaint, but obviously your data will be inconsistent. One advantage is that it takes less time to load, because again you are using load command, which is essentially copying the file from one location to another. Then you have dynamic partitioning. In dynamic partitioning, you'll have to set this configuration parameter Hive exec dynamic partition to true. There's one more configuration parameter, set Hive exec dynamic partition mode to non-strict, and then the partitions are created on the fly. So you can use the single file to load the partition table, and data with correct value would be loaded to the correct partition. But in this case, you'll have to use insert command to load the data, which will put the records into their corresponding partition automatically. You cannot use load command here. Obviously, it takes more time to load because you are using insert command. So similarly, you create external table partition by model year and then use the insert command to load the table and mention the partition keyword followed by the partition column. Obviously, before running insert command, you'll have to set these two configuration parameters, Hive exec dynamic partition to true and Hive exec dynamic partition mode to be non-strict. Let's talk about various configuration parameters for dynamic partitioning. I've already talked about Hive exec dynamic partition, which has to be set to true. So if you do not set to true, dynamic partition will not be enabled. You cannot use the insert statement to load a partition table dynamically. The next configuration parameter is Hive exec dynamic partition mode, which has to be either strict or non-strict. In strict mode, you have to mention at least one static partition in case we accidentally overwrite all partitions. So in non-strict mode, all partitions are allowed to be dynamic. Typically, we set this particular configuration parameter to be non-strict. Then you have Hive exec maximum dynamic partitions, which tells you the maximum number of dynamic partitions that are allowed to be created in total. Then there is one more configuration parameter, which is Hive error on empty partition. So it tells you, if you set it to true, it will tell you whether to throw an exception if dynamic partition insert generates empty results. There can be scenarios because maybe you have records wherein you do not have any value for the partition column. So in that case, it will generate empty partition. If it does and you set Hive error on empty partition to true, Hive will throw an error. There is one more concept called bucketing. Bucketing is not same as partitioning. It's a little different. So bucket actually divides the tables or partitions further into further subdivisions. So if you create a table and you mention that clustered by product ID into 4 buckets, use this cluster by keyword to tell Hive that you want to bucket using this particular column, in this case product ID, into 4 buckets, meaning Hive will create 4 different buckets. So you can create buckets for partition tables also. In this case, the table definition is create table name. The partition by is model year and cluster by is product ID, meaning that the partitioning would be done by model year, and in each partition the records would be bucketed by product ID. And then you mention the number of buckets, meaning that the records in each partition would go to 4 buckets. In the previous example, records for the entire table would go to 4 buckets. Now the question is, if you mention 4 buckets or 10 buckets or 20 buckets, how Hive would put records into individual buckets? So there's a formula. So bucket number is equal to the hash of the cluster column modulo number of partitions. In this case, bucket number would be equal to hash of the product value of the product ID, and then modulo 4 will give you the partition number. Let's say the hash of product ID is 5, then that particular record would go to bucket number 1. If hash of product ID comes out to be 10, then that particular record would go to bucket number 2, because 10 modulo 4 is 2, 2 being the remainder. If the value of hash and product ID comes out to be 4, that particular record would go to bucket number 0. Let's look at it pictorially. So this is the keyword which is used to create buckets. I've mentioned clustered by product ID into 4 buckets, and let's say I have partitions on model year. So I have 2 partitions, model year, one for model year 2021 and the second one is for model year 2022. Now 4 buckets would be created for each of these partitions. Now which record would go to which bucket, that would be dependent on the hash of product ID modulo 4. So value of product ID would be passed to the hash function. Whatever value comes out, it will be divided by 4, and the remainder, whatever is the remainder, that will be the bucket number. As usual, let us go ahead and have some hands-on on partitioning and bucketing.